Welcome. In this video I'm going to show you how you can perform a post-hoc residual analysis after a goodness of fit test using binary tests and R. I'm using a Jupyter Lab with an R kernel, but you should be able to use this also in, for example, RStudio. It's also possible to, these residual tests, they actually look at the categories and compare its observed counts with its expected counts. Alternatively, you could do goodness of fit test rather than binary test. I have a separate video on that. And you could also do pairwise comparisons. So then you take any possible combination of two categories and see if those are significantly different from each other. The R version that I'm using is version 4.3. And the only packages that I currently have running should be only the default packages. Now, for some reason, my R kernel is sometimes a little bit slow, so it says it's idle, but it's actually not done. So, as you can see, they're all installed. The default ones, like stats, that's going to be an interesting one for later on. I will need some example data, so I have a file from the General Social Survey from 2012, which I adjusted for some example purposes. I actually don't need the entire data frame. I just need one nominal field. And the nominal field I'll be using is the marital status. So I'll store that separately under nominal field and then dfmar1 for marital status. To give you a quick impression, there's the table function, and that will show us the counts. So if I run that, I should get the counts for the each category. So for example, 79 people indicated to be separated. I actually have a function in my own library, stikpet R, that can do all of this in one go. It's ph residual goodness of fit bin. But in this video, I won't be using that. I'll simply be using other libraries or do it the hard way. To give you a good view, I actually also prepare some expected counts. So for divorce 300, for married 1100. But if you don't have those, you could simply sum all those frequencies and divide by the number of categories. So once I have those, I also want the sum of all of the frequencies. I have to wait until my kernel is actually ready again, so that might take a little while. Or I could just restart the whole thing. Let me just do that. Shut down all, and then quickly restart. Sorry for the scrolling. Version. Of course, it does need to restart the kernel. It should be done by now. Yep. Let's hope it goes slightly faster now. Load this one in as well. And of course the nominal field. The loading takes a little bit long, of course, because it needs to download the file from the website. The expected counts, yes, and now it's going a little bit more smooth. The stats library has a chi-square test function, and with that you can actually get as a bonus the residual. So the only thing is you need to enter the expected counts as a proportion, so divided by the total count. And then you actually get the standardized residuals. Although in R they call these residuals, but I think the residual is just observed minus the expected count, so these are already standardized. And since they're standardized, they could be seen as so-called Z values, and then you could use the normal distribution, so like a Z test on each of them. For that you can use the pnorm function, which is actually the normal distribution cumulative density function, and that should give you then for all of the for each of them the the p-value. I'm multiplying this with the number of tests that we're actually doing, so that's like a Bonferroni multiple testing correction. As you can see, the first one is seems to be 0.2, so that's above the usual 0.05 threshold. This one is just below it. This one is far below it. This one is the e minus 0.1 means to divide it by 10 to the power of 1, so this is going to be 0.10 above the usual threshold of 0.05. and similar here also above it. So only married and never married were significantly different from what we've expected. If you like, you can also do the adjusted standardized residuals, but those are available as standardized residuals, just for the confusion. Um, and then you can do the same thing, and then you get those. Um, there's also an R statics library, because this is all you can do with the stats library. But if you want to do a binomial test, then you can actually use the R statics library. First, of course, you need to install it, and after you've installed it, you can import it. Then we can simply use the function. We can say which method we want to use for our multiple testing, and we should get similar results as with the stikpet R library. As you can see, we get quite a lot of output, but probably the most important one is that adjusted p-values. We can also assign those expected counts, but then as expected proportions, and that should give us similar results. Well, not the same as here, of course, because now we actually have expected counts used, and the rstatics also caters for that. But that's only with a binomial test. If you wanted to do, for example, um, a proportion test, like a score or a wall test, then that's not possible. You could, of course, not use any libraries, besides perhaps for the distributions. But we can say, for example, I'm going to be using the nominal field. I remove, first of all the missing values. I get again my observed counts. The names of the table are my categories. And again, I'm setting the expected counts. Then we can perform any of the one sample binary tests. So for example, a binomial test, and we simply loop over all the possible categories. So here I'm doing the binomial test. I have separate videos on how to do binomial test, the score test, proportion test, etc. The WALT. So I'm quickly running over this. The results are then the p-value, and we can get the adjusted p-values, and then we just print the results, and we get ourselves for divorced, for married, and every time we see the p-value and the adjusted p-value. For the residuals, you can actually do it also without the stats library chi-square test. So we simply take the results that we had earlier, and then we're going to build that up. We're going to say we're going to take the observed count, we'll subtract the expected count, and divide that by the square root of the expected count. That's the formula for the standardized residuals. The significance is then that p-norm again, and that should give us enough to show us the category, the z-value, the significance, and the adjusted significance. If you wanted to use those standardized adjusted residuals, then this becomes the formula. So you can notice that the denominator has become a little bit bigger. Get similar results, and that's about it. Alright, I hope this video was helpful, and thank you for watching.